we should act now. And they're getting better very, very fast, right? I testified in the Senate that, we might have serious bio risks within 2 to 3 years. That was about a year ago. Things have proceeded apace. So we have this thing where it's like it's surprisingly hard to address these risks because they're not here today. They don't exist. They're like ghosts, but they're coming at us so fast because the models are improving so fast. So how do you deal with something that's not here today, doesn't exist, but is coming at us very fast? So the solution we came up with for that, in collaboration with people like the organization Meter and Paul Cristiano, is okay. What you need for that are you need tests to tell you when the risk is getting close. You need an early warning system, and so every time we have a new model, we test it for its capability to do these CBRN tasks, as well as testing it for, how capable it is of doing tasks autonomously on its own. And in the latest version of our RSP, which we released in the last month or two, the way we test autonomy risks is the AI model's ability to do aspects of AI research itself. Which when the AI models can do AI research, they become kind of truly autonomous. And that threshold is important for a bunch of other ways. And so what do we then do with these tasks? The RSP basically develops what we've called an if-then structure, which is if the models pass a certain capability, then we impose a certain set of safety and security requirements on them. So today's models are what's called ASL2. Models that were ASL1 is for systems that manifestly don't pose any risk of autonomy or misuse. So, for example, a chess playing bot, Deep Blue, would be ASL1. It's just manifestly the case that you can't use Deep Blue for anything other than chess. It was just designed for chess. No one's going to use it to conduct a masterful cyber attack or to, run wild and take over the world. ASL2 is today's AI systems, where we've measured them and we think these systems are simply not smart enough to autonomously self-replicate or conduct a bunch of tasks, and also not smart enough to provide meaningful information about CBRN risks and how to build CBRN weapons above and beyond what can be known from looking at Google. In fact, sometimes they do provide information, but not above and beyond a search engine, but not in a way that can be stitched together. Not in a way that kind of end to end is dangerous enough. So ASL3 is going to be the point at which the models are helpful enough to enhance the capabilities of non-state actors, right? State actors can already do a lot of, unfortunately, to a high level of proficiency, a lot of these very dangerous and destructive things. The difference is that non-state actors are not capable of it. And so when we get to ASL3, we'll take special security precautions designed to be sufficient to prevent theft of the model by non-state actors and misuse of the model as it's deployed. We'll have to have enhanced filters targeted at these particular areas.
Cyber, bio, nuclear,
and model autonomy, which is less a misuse risk and more a risk of the model doing bad things itself. ASL4, getting to the point where these models could enhance the capability of a already knowledgeable state actor and or become the main source of such a risk. Like if you wanted to engage in such a risk, the main way you would do it is through a model. And then I think ASL4 on the autonomy side, it's some amount of acceleration in AI research capabilities with an AI model. And then ASL5 is where we would get to the models that are kind of truly capable, that could exceed humanity in their ability to do any of these tasks. And so the point of the if-then structure commitment is basically to say, look, I don't know. I've been working with these models for many years, and I've been worried about risk for many years. It's actually kind of dangerous to cry wolf. It's actually kind of dangerous to say this model is risky, and people look at it and they say this is manifestly not dangerous. Again, it's the the delicacy of the risk isn't here today, but it's coming at us fast. How do you deal with that? It's really vexing to a risk planner to deal with it. And so this if-then structure basically says, look, we don't want to antagonize a bunch of people. We don't want to harm our own, our kind of own ability to have a place in the conversation by imposing these very onerous burdens on models that are not dangerous today. So the if-then, the trigger commitment, is basically a way to deal with this. It says you clamp down hard when you can show that the model is dangerous. And of course, what has to come with that is, enough of a buffer threshold that you're not at high risk of kind of missing the danger. It's not a perfect framework. We've had to change it every we came out with a new one just a few weeks ago, and probably going forward, we might release new ones multiple times a year because it's hard to get these policies right, like technically, organizationally, from a research perspective. But that is the proposal. If-then commitments and triggers in order to minimize burdens and false alarms now, but really react appropriately when the dangers are here.
What do you think the timeline for ASL3 is, where several of the triggers are fired? And what do you think the timeline is for ASL4?
Yeah, so that is hotly debated within the company. We are working actively to prepare ASL3 security measures as well as ASL3 deployment measures. I'm not going to go into detail, but we've made a lot of progress on both, and we're prepared to be, I think, ready quite soon. I would not be surprised. I would not be surprised at all if we hit ASL3 next year. There was some concern that we might even hit it this year. That's still possible. That could still happen. It's very hard to say, but I would be very, very surprised if it was 2030. I think it's much sooner than that.
So there's protocols for detecting it, the if-then, and then there's protocols for how to respond to it.
Yes.
How difficult is the latter?
I think for ASL3, it's primarily about security and about filters on the model relating to a very narrow set of areas when we deploy the model. Because at ASL3, the model isn't autonomous yet. And so you don't have to worry about, kind of the model itself behaving in a bad way even when it's deployed internally. So I think the ASL3 measures are I won't say straightforward. They're rigorous, but they're easier to reason about. I think once we get to ASL4, we start to have worries about the models being smart enough that they might sandbag tests. They might not tell the truth about tests. We had some results came out about sleeper agents, and there was a more recent paper about, can the models mislead attempts to, sandbag their own abilities, right? Show them, present themselves as being less capable than they are. And so I think with ASL4, there's going to be an important component of using other things than just interacting with the models. For example, interpretability or hidden chains of thought, where you have to look inside the model and verify via some other mechanism that is not as easily corrupted as what the model says, that the model indeed has some property. So we're still working on ASL4. One of the properties of the RSP is that we don't specify ASL4 until we've hit ASL3. Yeah. And I think that's proven to be a wise decision, because even with ASL3, it's hard to know this stuff in detail. And we want to take as much time as we can possibly take to get these things right.
So for ASL3, the bad actor will be the humans.
Yes.
And so there's a little bit more...
for ASL4, it's both, I think.
It's both. And so deception, and that's where mechanistic interpretability comes into play. And hopefully the techniques used for that are not made accessible to the model.
Yeah, I mean, of course, you can hook up the mechanistic interpretability to the model itself, but then you've kind of lost it as a reliable indicator of the model state. There are a bunch of exotic ways you can think of that it might also not be reliable, like if the model gets smart enough that it can jump computers and like read the code where you're like looking at its internal state. We've thought about some of those. I think they're exotic enough. There are ways to render them unlikely. But yeah, generally you want to preserve mechanistic interpretability as a kind of verification set or test set that's separate from the training process of the model.
See, I think as these models become better and better conversation and become smarter, social engineering becomes a threat too, because they they can start being very convincing to the engineers inside companies.
Oh yeah. It's actually like, we've seen lots of examples of demagoguery in our life from humans, and there's a concern that models could do that as well.
One of the ways that Claude has been getting more and more powerful is it's now able to do some agentic stuff. Computer use. There's also an analysis within the sandbox of Claude.ai itself, but let's talk about computer use. That seems to me super exciting, that you can just give Claude a task and it takes a bunch of actions, figures it out, and has access to your computer through screenshots. So can you explain how that works and where that's headed?
Yeah, it's actually relatively simple. So Claude has had for a long time, since Claude 3 back in March, the ability to analyze images and respond to them with text. The only new thing we added is those images can be screenshots of a computer. And in response, we train the model to give a location on the screen where you can click and or buttons on the keyboard you can press in order to take action. And it turns out that with actually not all that much additional training, the models can get quite good at that task. It's a good example of generalization. People sometimes say if you get to low Earth orbit, you're like halfway to anywhere, right? Because of how much it takes to escape the gravity well. If you have a strong pre-trained model, I feel like you're halfway to anywhere in terms of the intelligence space. And so actually it didn't take all that much to get Claude to do this. And you can just set that in a loop. Give the model a screenshot, tell it what to click on, give it the next screenshot, tell it what to click on. And that turns into a full kind of almost 3D video interaction of the model. And it's able to do all of these tasks, right? We showed these demos where it's able to like fill out spreadsheets. It's able to kind of like interact with a website. It's able to, it's able to open all kinds of, programs, different operating systems, Windows, Linux, Mac. So I think all of that is very exciting. I will say, while in theory, there's nothing you could do there that you couldn't have done through just giving the model the API to drive the computer screen. This really lowers the barrier, and there's a lot of folks who either kind of aren't in a position to interact with those APIs, or it takes them a long time to do. It's just the screen is just a universal interface that's a lot easier to interact with, and so I expect over time this is going to lower a bunch of barriers. Now, honestly, the current model it leaves a lot still to be desired, and we were honest about that in the blog, right? It makes mistakes, it misclicks, and we were careful to warn people, hey, this thing isn't. You can't just leave this thing to run on your computer for minutes and minutes. You got to give this thing boundaries and guardrails, and I think that's one of the reasons we released it first in an API form rather than kind of this kind of just hand it to the consumer and give it control of their computer. But I definitely feel that it's important to get these capabilities out there. As models get more powerful, we're going to have to grapple with how do we use these capabilities safely? How do we prevent them from being abused? And I think releasing the model while the capabilities are still limited is very helpful in terms of doing that. I think since it's been released, a number of customers, I think Replit was maybe one of the most quickest to deploy things. Have made use of it in various ways. People have hooked up demos for Windows desktops, Macs, Linux machines. So yeah, it's been very exciting. I think as with anything else, it comes with new exciting abilities, and then with those new exciting abilities, we have to think about how to make the model safe, reliable, do what humans want them to do. I mean, it's the same story for everything, right? Same thing. It's that same tension.
But the possibility of use cases here is just the range is incredible. So how much to make it work really well in the future? how much do you have to specially kind of go beyond what's the pre-trained models doing, do more post-training RLHF or supervised fine-tuning or synthetic data just for the agentic
Yeah,
stuff?
I think speaking at a high level, it's our intention to keep investing a lot in making the model better. Like we look at some of the some of the benchmarks where previous models were like, oh, it could do it 6% of the time, and now our model would do it 14 or 22% of the time. And yeah, we want to get up to the human level reliability of 80-90%, just like anywhere else, right? We're on the same curve that we were on with SWE-bench, where I would guess a year from now the models can do this very, very reliably. But you got to start somewhere.
So you think it's possible to get to the human level, 90%, basically doing the same thing you're doing now, or is it has to be special for computer use?
I mean, it depends what you mean by special in general. But I generally think the same kinds of techniques that we've been using to train the current model. I expect that doubling down on those techniques in the same way that we have for code, for models in general, for image input, for voice, I expect those same techniques will scale here as they have everywhere else.
But this is giving sort of the power of action to Claude. And so you could do a lot of really powerful things, but you could do a lot of damage also.
Yeah. No, and we've been very aware of that. Look, my view actually is computer use isn't a fundamentally new capability like these CBRN or autonomy capabilities are. It's more like it kind of opens the aperture for the model to use and apply its existing abilities. And so the way we think about it, going back to our RSP, is nothing that this model is doing inherently increases, the risk from an RSP perspective. But as the models get more powerful, having this capability may make it scarier once it has the cognitive capability to do something at the ASL 3 and ASL 4 level. This may be the thing that kind of unbounds it from doing so. So going forward, certainly this modality of interaction is something we have tested for and that we will continue to test for in RSP going forward. I think it's probably better to learn and explore this capability before the model is super capable.
Yeah, and there's a lot of interesting attacks like prompt injection, because now you've widened the aperture so you can prompt inject through stuff on screen. So if this becomes more and more useful, then there's more and more benefit to inject stuff into the model. If it goes to a certain web page, it could be harmless stuff like advertisements, or it could be like harmful stuff, right?
Yeah, I mean, we've thought a lot about things like spam, CAPTCHA, mass camp. There's all, every like, if one secret I'll tell you, if you've invented a new technology, not necessarily the biggest misuse, but the first misuse you'll see, scams, just petty scams. Like you'll just it's like a thing as old, people scamming each other. It's this thing as old as time. And it's just every time you got to deal with it.
It's almost like silly to say, but it's true. Sort of bots and spam in general is a thing as it gets more and more intelligent.
Yeah,
it's
just
harder to
there are a
fight.
lot of like I said, like there are a lot of petty criminals in the world, and it's like every new technology is like a new way for petty criminals to do something something stupid and malicious.
Is there any ideas about sandboxing it? Like, how difficult is the sandboxing task?
Yeah, we sandbox during training. So, for example, during training, we didn't expose the model to the internet. I think that's probably a bad idea during training because, the model can be changing its policy. It can be changing what it's doing, and it's having an effect in the real world. In terms of actually deploying the model, right, it kind of depends on the application. Like, sometimes you want the model to do something in the real world, but of course you can always put guardrails on the outside, right? You can say, okay, well, this model's not going to move data from my, this model's not going to move any files from my computer or my web server to anywhere else. Now, when you talk about sandboxing, again, when we get to ASL4, none of these precautions are going to make sense there, right? Where when you talk about ASL4, you're then the model is being kind of, there's a theoretical worry the model could be smart enough to break it, to kind of break out of any box. And so there we need to think about mechanistic interpretability, about, if we're going to have a sandbox, it would need to be a mathematically provable sandbox. That's a whole different world than what we're dealing with the models today.
Yeah, the science of building a box from which ASL4 AI system cannot escape.
I think it's probably not the right approach. I think the right approach, instead of having something, unaligned that like you're trying to prevent it from escaping, I think it's better to just design the model the right way, or have a loop where you look inside the model and you're able to verify properties, and that gives you an opportunity to like iterate and actually get it right. I think containing bad models is much worse solution than having good models.
Let me ask about regulation. What's the role of regulation in keeping AI safe? So, for example, can you describe California AI Regulation Bill SB 1047 that was ultimately vetoed by the governor? What are the pros and cons of this bill?
Yes,
in general?
we ended up making some suggestions to the bill, and then some of those were adopted, and we felt I think quite positively about the bill by the end of that. It did still have some downsides. And of course it got vetoed. I think at a high level, I think some of the key ideas behind the bill are, I would say, similar to ideas behind our RSPs. And I think it's very important that some jurisdiction, whether it's California or the federal government and or other countries and other states, passes some regulation like this. And I can talk through why I think that's so important. So I feel good about our RSP. It's not perfect. It needs to be iterated on a lot, but it's been a good forcing function for getting the company to take these risks seriously, to put them into product planning, to really make them a central part of work at Anthropic, and to make sure that all of 1,000 people, and it's almost 1,000 people now at Anthropic, understand that this is one of the highest priorities of the company, if not the highest priority. But one, there are still some companies that don't have RSP-like mechanisms, like OpenAI, Google did adopt these mechanisms a couple months after Anthropic did. But there are other companies out there that don't have these mechanisms at all. And so if some companies adopt these mechanisms and others don't, it's really going to create a situation where, some of these dangers have the property that it doesn't matter if 3 out of 5 of the companies are being safe. If the other 2 are being unsafe, it creates this negative externality. And I think the lack of uniformity is not fair to those of us who have put a lot of effort into being very thoughtful about these procedures. The second thing is, I don't think you can trust these companies to adhere to these voluntary plans on their own, right? I like to think that Anthropic will. We do everything we can that we will. Our RSP is checked by our long-term benefit trust. So we do everything we can to adhere to our own RSP. But you hear lots of things about various companies saying, "Oh, they said they would give this much compute and they didn't. They said they would do this thing and they didn't." I don't think it makes sense to litigate particular things that companies have done. But I think this broad principle that, like, if there's nothing watching over them, if there's nothing watching over us as an industry, there's no guarantee that we'll do the right thing, and the stakes are very high. And so I think it's important to have a uniform standard that everyone follows, and to make sure that the industry does what a majority of the industry has already said is important and has already said that they definitely will do. Right? Some people, I think there's a class of people who are against regulation on principle. I understand where that comes from. If you go to Europe and you see something like GDPR, you see some of the other stuff that they've done. Some of it's good, but some of it is really unnecessarily burdensome, and I think it's fair to say really has slowed innovation. And so I understand where people are coming from on priors. I understand why people start from that position. But again, I think AI is different. If we go to the very serious risks of autonomy and misuse that I talked about, just a few minutes ago, I think that those are unusual and they warrant an unusually strong response. And so I think it's very important. Again, we need something that everyone can get behind. I think one of the issues with SB 1047, especially the original version of it, was it had a bunch of the structure of RSPs, but it also had a bunch of stuff that was either clunky or that just would have created a bunch of burdens, a bunch of hassle, and might even have missed the target in terms of addressing the risks. You don't really hear about it on Twitter. You just hear about kind of, people are cheering for any regulation, and then the folks who are against make up these often quite intellectually dishonest arguments about how, it'll make us move away from California. Bill doesn't apply if you're headquartered in California. Bill only applies if you do business in California, or that it would damage the open source ecosystem, or that it would cause all of these things. I think those were mostly nonsense, but there are better arguments against regulation. There's one guy, Dean Ball, who's really, I think a very scholarly analyst who looks at what happens when a regulation is put in place and ways that they can kind of get a life of their own, or how they can be poorly designed. And so our interest has always been, we do think there should be regulation in this space, but we want to be an actor who makes sure that regulation is something that's surgical, that's targeted at the serious risks, and is something people can actually comply with. Because something I think the advocates of regulation don't understand as well as they could is if we get something in place that is that's poorly targeted, that wastes a bunch of people's time, what's going to happen is people are going to say, see, these safety risks, they're, this is nonsense. I just had to hire 10 lawyers to fill out all these forms. I had to run all these tests for something that was clearly not dangerous. And after 6 months of that, there will be a groundswell, and we'll end up with a durable consensus against regulation. And so I think the worst enemy of those who want real accountability is badly designed regulation. We need to actually get it right. And this is, if there's one thing I could say to the advocates, it would be that I want them to understand this dynamic better. And we need to be really careful, and we need to talk to people who actually have experience seeing how regulations play out in practice. And the people who have seen that understand to be very careful. If this was some lesser issue, I might be against regulation at all. But what I want the opponents to understand is that the underlying issues are actually serious. They're not something that I or the other companies are just making up because of regulatory capture. They're not sci-fi fantasies. They're not any of these things. Every time we have a new model, every few months, we measure the behavior of these models, and they're getting better and better at these concerning tasks, just as they are getting better and better at, good, valuable, economically useful tasks. And so I would just love it if some of the former, I think SB 1047 was very polarizing. I would love it if some of the most reasonable opponents and some of the most reasonable proponents would sit down together and, I think that, the different AI companies, Anthropic was the only AI company that, felt positively in a very detailed way. I think Elon tweeted briefly something positive, but some of the big ones like Google, OpenAI, Meta, Microsoft were pretty staunchly against. So I would really like is if some of the key stakeholders, some of the most thoughtful proponents and some of the most thoughtful opponents would sit down and say, how do we solve this problem in a way that the proponents feel brings a real reduction in risk, and that the opponents feel that it is not hampering the industry or hampering innovation any more necessary than it needs to. And I think for whatever reason that things got too polarized and those two groups didn't get to sit down in the way that they should. And I feel urgency. I really think we need to do something in 2025. if we get to the end of 2025 and we've still done nothing about this, then I'm going to be worried. I'm not worried yet because, again, the risks aren't here yet. But I think time is running short.
Yeah, and come up with something surgical, like you said.
Yeah, exactly. And we need to get away from this intense pro safety versus intense anti-regulatory rhetoric, right? It's turned into these flame wars on Twitter, and nothing good's going to come of that.
So there's a lot of curiosity about the different players in the game. One of the OGs is OpenAI. You've had several years of experience at OpenAI. What's your story and history there?
Yeah, so I was at OpenAI for roughly 5 years. For the last, I think it was a couple of years, I was vice president of research there. Probably myself and Ilya Sutskever were the ones who, really kind of set the research direction around 2016 or 2017. I first started to really believe in, or at least confirm my belief in, the scaling hypothesis when Ilya famously said to me, the thing you need to understand about these models is they just want to learn. The models just want to learn. And again, sometimes there are these one sentences, these Zen koans that you hear them and you're like, that explains everything. That explains like 1,000 things that I've seen. And then I ever after I had this visualization in my head of like, you optimize the models in the right way. You point the models in the right way. They just want to learn. They just want to solve the problem, regardless of what the problem is.
So get out of their way, basically.
Get out of their way. Yeah. Okay. Don't impose your own ideas about how they should learn. And, if this was the same thing as Rich Sutton put out in The Bitter Lesson, or Gurn put out in The Scaling Hypothesis. I think generally the dynamic was, I got this kind of inspiration from Ilya and from others, folks like Alec Radford, who did the original GPT-1, and then ran really hard with it, me and my collaborators, on GPT-2, GPT-3, RL from Human Feedback, which was an attempt to kind of deal with the early safety and durability, things like debate and amplification, heavy on interpretability. So again, the combination of safety plus scaling, probably 2018, 2019, 2020, those were kind of the years when myself and my collaborators, probably, many of whom became co-founders of Anthropic, kind of really had a vision and drove the direction.
Why'd you leave? Why'd you decide to leave?
Yeah. So look, I'm going to put things this way, and I think it ties to the race to the top, right? Which is, in my time at OpenAI, what I'd come to see as I'd come to appreciate the scaling hypothesis, and as I'd come to appreciate kind of the importance of safety along with the scaling hypothesis. The first one, I think, OpenAI was getting on board with. The second one, in a way, had always been part of OpenAI's messaging. But over many years of the time that I spent there, I think I had a particular vision of how we should handle these things, how we should be brought out in the world, the kind of principles that the organization should have. And look, I mean, there were like many, many discussions about should the company do this? Should the company do that? Like, there's a bunch of misinformation out there. People say we left because we didn't like the deal with Microsoft. False. Although, there was a lot of discussion, a lot of questions about exactly how we do the deal with Microsoft. We left because we didn't like commercialization. That's not true. We built GPT-3, which was the model that was commercialized. I was involved in commercialization. It's more, again, about how do you do it? Like, civilization is going down this path to very powerful AI. What's the way to do it that is cautious, straightforward, honest, that builds trust in the organization and in individuals? How do we get from here to there? And how do we have a real vision for how to get it right? How can safety not just be something we say because it helps with recruiting? I think at the end of the day, if you have a vision for that, forget about anyone else's vision. I don't want to talk about anyone else's vision. If you have a vision for how to do it, you should go off and you should do that vision. Mm-hmm. It is incredibly unproductive to try and argue with someone else's vision. You might think they're not doing it the right way. You might think they're dishonest. Who knows? Maybe you're right. Maybe you're not. But what you should do is you should take some people you trust and you should go off together and you should make your vision happen. And if your vision is compelling, if you can make it appeal to people, some combination of ethically, in the market. If you can make a company that's a place people want to join, that engages in practices that people think are reasonable while managing to maintain its position in the ecosystem at the same time. If you do that, people will copy it. And the fact that you are doing it, especially the fact that you're doing it better than they are, causes them to change their behavior in a much more compelling way than if they're your boss and you're arguing with them. I don't know how to be any more specific about it than that, but I think it's generally very unproductive to try and get someone else's vision to look like your vision. It's much more productive to go off and do a clean experiment and say, this is our vision. This is how we're going to do things. Your choice is you can ignore us, you can reject what we're doing, or you can start to become more like us. And imitation is the sincerest form of flattery. And that plays out in the behavior of customers, that plays out in the behavior of the public, that plays out in the behavior of where people choose to work. And again, at the end, it's not about one company winning or another company winning. If we or another company are engaging in some practice that people find genuinely appealing, and I want it to be in substance, not just in appearance. I think researchers are sophisticated and they look at substance. And then other companies start copying that practice and they win because they copied that practice. That's great. That's success. That's like the race to the top. It doesn't matter who wins in the end, as long as everyone is copying everyone else's good practices, right? One way I think of it is like, the thing we're all afraid of is the race to the bottom, right? And the race to the bottom doesn't matter who wins because we all lose, right? Like, in the most extreme world, we make this autonomous AI that, the robots enslave us or whatever, right? I mean, that's half joking, but, that is the most extreme thing that could happen. Then it doesn't matter which company was ahead. If instead you create a race to the top where people are competing to engage in good practices, then at the end of the day, it doesn't matter who ends up winning. It doesn't even matter who started the race to the top. The point isn't to be virtuous. The point is to get the system into a better equilibrium than it was before. And individual companies can play some role in doing this. Individual companies can help to start it, can help to accelerate it. And frankly, I think individuals at other companies have done this as well, right? The individuals that, when we put out an RSP, react by pushing harder to get something similar done at other companies. Sometimes other companies do something that's like, we're like, oh, it's a good practice. We think that's good. We should adopt it too. The only difference is, I think we are, we try to be more forward leaning. We try and adopt more of these practices first and adopt them more quickly when others invent them. But I think this dynamic is what we should be pointing at. And that I think it abstracts away the question of, which company's winning, who trusts who. I think all these questions of drama are profoundly uninteresting. And the thing that matters is the ecosystem that we all operate in and how to make that ecosystem better, because that constrains all the players.
And so Anthropic is this kind of clean experiment built on a foundation of like what concretely AI safety should look like.
I'm sure we've made plenty of mistakes along the way. The perfect organization doesn't exist. It has to deal with the imperfection of 1,000 employees. It has to deal with the imperfection of our leaders, including me. It has to deal with the imperfection of the people we've put to oversee the imperfection of the leaders, like the board and the long-term benefit trust. It's all a set of imperfect people trying to aim imperfectly at some ideal that will never perfectly be achieved. That's what you sign up for. That's what it will always be. But imperfect doesn't mean you just give up. There's better and there's worse. And hopefully we can do well enough that we can begin to build some practices that the whole industry engages in. And then, my guess is that multiple of these companies will be successful. Anthropic will be successful. These other companies, like ones I've been at the past, will also be successful. And some will be more successful than others. That's less important than, again, that we align the incentives of the industry. And that happens partly through the race to the top, partly through things like RSP, partly through, again, selected surgical regulation.
You said talent density beats talent mass. So can you explain that? Can you expand on
Yeah.
it? Can you just talk about what it takes to build a great team of AI researchers and engineers?
This is one of these statements that's like more true every month. Every month I see this statement as more true than I did the month before. So if I were to do a thought experiment, let's say you have a team of 100 people that are super smart, motivated, and aligned with the mission, and that's your company. Or you can have a team of 1,000 people where 200 people are super smart, super aligned with the mission, and then and then like 800 people are, let's just say you pick 800 like random big tech employees. Which would you rather have, right? The talent mass is greater in the group of 1,000 people, right? You have even a larger number of incredibly talented, incredibly aligned, incredibly smart people. But the issue is just that if every time someone super talented looks around, they see someone else super talented and super dedicated, that sets the tone for everything, right? That sets the tone for everyone is super inspired to work at the same place. Everyone trusts everyone else. If you have 1,000 or 10,000 people and things have really regressed, right? You are not able to do selection and you're choosing random people. What happens is then you need to put a lot of processes and a lot of guardrails in place. Just because people don't fully trust each other, or you have to adjudicate political battles. Like there are so many things that slow down the org's ability to operate. And so we're nearly 1,000 people. And, you know, we've tried to make it so that as large a fraction of those 1,000 people as possible are like super talented, super skilled. It's one of the reasons we've slowed down hiring a lot in the last few months. We grew from 300 to 800, I think, in the first 7-8 months of the year. And now we've slowed down. We're at like, you know, the last 3 months, we went from 800 to 900, 950, something like that. Don't quote me on the exact numbers, but I think there's an inflection point around 1,000, and we want to be much more careful how we grow. Early on and now as well, you know, we've hired a lot of physicists. You know, theoretical physicists can learn things really fast. Even more recently, as we've continued to hire that, you know, we've really had a high bar on both the research side and the software engineering side, have hired a lot of senior people, including folks who used to be at other companies in this space. And we've just continued to be very selective. It's very easy to go from 100 to 1,000 and 1,000 to 10,000 without paying attention to making sure everyone has a unified purpose. It's so powerful. If your company consists of a lot of different fiefdoms that all want to do their own thing, that are all optimizing for their own thing, it's very hard to get anything done. But if everyone sees the broader purpose of the company, if there's trust and there's dedication to doing the right thing, that is a superpower. That in itself, I think, can overcome almost every other disadvantage.
And, you know, it's the Steve Jobs A players. A players want to look around and see other A players, is another way of saying
Correct.
that. I don't know what that is about human nature, but it is demotivating to see people who are not obsessively driving towards a singular mission. And it is, on the flip side of that, super motivating to see that. It's interesting. What's it take to be a great AI researcher or engineer from everything you've seen, from working with so many amazing people?
Yeah. I think the number one quality, especially on the research side, but really both, is open-mindedness. Sounds easy to be open-minded, right? You're just like, oh, I'm open to anything. But you know, if I think about my own early history in the scaling hypothesis, I was seeing the same data others were seeing. I don't think I was like a better programmer or better at coming up with research ideas than any of the hundreds of people that I worked with. In some ways I was worse. You know, like I've never like, you know, precise programming of like, you know, finding the bug, writing the GPU kernels. Like I could point you to 100 people here who are better at that than I am. But the thing that I think I did have that was different was that I was just willing to look at something with new eyes, right? People said, oh, you know, we don't have the right algorithms yet. We haven't come up with the right way to do things. And I was just like, oh, I don't know. Like, you know, this neural net has like 30 million parameters. Like, what if we gave it 50 million instead? Like, let's plot some graphs. Like that basic scientific mindset of like, oh man, like I I see some variable that I could change. Like, what happens when it changes? Like, let's try these different things and like create a graph for even this. This was like the simplest thing in the world, right? Change the number of, this wasn't like PhD level experimental design. This was like simple and stupid. Like, anyone could have done this if you just told them that it was important. It's also not hard to understand. You didn't need to be brilliant to come up with this. But you put the two things together, and some tiny number of people, some single digit number of people have driven forward the whole field by realizing this. And it's, it's often like that. If you look back at the discoveries in history, they're often like that. And so this open-mindedness and this willingness to see with new eyes that often comes from being newer to the field. Often experience is a disadvantage for this. That is the most important thing. It's very hard to look for and test for, but I think it's the most important thing, because when you find something, some really new way of thinking about things, when you have the initiative to do that, it's absolutely transformative.
And also be able to do kind of rapid experimentation, and in the face of that, be open-minded and curious and looking at the data with just these fresh eyes and seeing what is that it's actually saying. That applies in mechanistic interpretability.
It's another example of this. Like, some of the early work in mechanistic interpretability, so simple. It's just no one thought to care about this question before.
You said what it takes to be a great AI researcher. Can we rewind the clock back? What advice would you give to people interested in AI? They're young, looking forward. How can I make an impact on the world?
I think my number one piece of advice is to just start playing with the models. Yeah. This was actually, I worry a little. This seems like obvious advice now. I think 3 years ago, it wasn't obvious, and people started by, let me read the latest reinforcement learning paper. Let me kind of, no, I mean, that was really and I mean, you should do that as well. But now, with wider availability of models and APIs, people are doing this more. But I think just experiential knowledge. These models are new artifacts that no one really understands. And so getting experience playing with them. I would also say, again, in line with the do something new, think in some new direction. There are all these things that haven't been explored. Like, for example, mechanistic interpretability is still very new. It's probably better to work on that than it is to work on new model architectures, because it's more popular than it was before. There are probably 100 people working on it, but there aren't 10,000 people working on it. And it's this fertile area for study. There's so much low-hanging fruit. You can just walk by and you can pick things. And the only reason, for whatever reason, people aren't interested in it enough. I think there are some things around long horizon learning and long horizon tasks where there's a lot to be done. I think evaluations we're still very early in our ability to study evaluations, particularly for dynamic systems acting in the world. I think there's some stuff around multi-agent. Skate where the puck is going is my advice. And you don't have to be brilliant to think of it. All the things that are going to be exciting in 5 years, in people even mention them as conventional wisdom, but it's just somehow there's this barrier that people don't double down as much as they could, or they're afraid to do something that's not the popular thing. I don't know why it happens, but getting over that barrier is my number one piece of advice.
Let's talk, if we could, a bit about post-training.
Yeah.
So it seems that the modern post-training recipe has a little bit of everything. So supervised fine-tuning, RLHF, the constitutional AI with RLAIF.
Best acronym.
It's again that naming thing. And then synthetic data. Seems like a lot of synthetic data, or at least trying to figure out ways to have high quality synthetic data. So what's the, if this is a secret sauce that makes Anthropic Claude so incredible, how much of the magic is in the pre-training? How much of it is in the post-training?
Yeah. So first of all, we're not perfectly able to measure that ourselves. Sure. When you see some great character ability, sometimes it's hard to tell whether it came from pre-training or post-training. We've developed ways to try and distinguish between those two, but they're not perfect. The second thing I would say is, it's when there is an advantage, and I think we've been pretty good at in general at RL, perhaps the best, although I don't know because I don't see what goes on inside other companies. usually it isn't, oh my God, we have this secret magic method that others don't have, right? Usually it's like, well, we got better at the infrastructure, so we could run it for longer, or, we were able to get higher quality data, or we were able to filter our data better, or we were able to, combine these methods in practice. It's usually some boring matter of kind of practice and tradecraft. So, when I think about how to do something special in terms of how we train these models, both pre-training, but even more so post-training, I really think of it a little more, again, as like designing airplanes or cars. Like, it's not just like, oh man, I have the blueprint. Like maybe that makes you make the next airplane, but like there's some cultural tradecraft of how we think about the design process that I think is more important than any particular gizmo we're able to invent.
Okay, well, let me ask you about specific techniques. So first on RLHF, what do you think? Just zooming out, intuition, almost philosophy. Why do you think RLHF works so well?
If I go back to like the scaling hypothesis, one of the ways to skate the scaling hypothesis is if you train for X and you throw enough compute at it, then you get X. And so RLHF is good at doing what humans want the model to do, or at least, to state it more precisely, doing what humans who look at the model for a brief period of time and consider different possible responses, what they prefer as the response, which is not perfect from both a safety and capabilities perspective, in that humans are often not able to perfectly identify what the model wants, and what humans want in the moment may not be what they want in the long term. So there's a lot of subtlety there, but the models are good at producing what the humans in some shallow sense want. And it actually turns out that you don't even have to throw that much compute at it because of another thing, which is this thing about a strong pre-trained model being halfway to anywhere. So once you have the pre-trained model, you have all the representations you need to get the model where you want it to go.
So do you think RLHF makes the model smarter or just appears smarter to the humans?
I don't think it makes the model smarter. I don't think it just makes the model appear smarter. It's like RLHF like bridges the gap between the human and the model, right? I could have something really smart that like can't communicate at all, right? We all know people like this, people who are really smart, but you can't understand what they're saying. So I think RLHF just bridges that gap. I think it's not the only kind of RL we do. It's not the only kind of RL that will happen in the future. I think RL has the potential to make models smarter, to make them reason better, to make them operate better, to make them develop new skills even. Mm-hmm. And perhaps that could be done, even in some cases with human feedback. But the kind of RLHF we do today mostly doesn't do that yet, although we're very quickly starting to be able to.
But it appears to sort of increase, if you look at the metric of helpfulness, it increases that.
It also increases, what was this word in Leopold's essay, unhobbling, where basically the models are hobbled and then you do various trainings to them to unhobble them. Yeah. So I like that word because it's like a rare word, but so I think RLHF unhobbles the models in some ways. And then there are other ways where a model hasn't yet been unhobbled and needs to unhobble.
If you can say, in terms of cost, is pre-training the most expensive thing, or is post-training creep up to that?
At the present moment, it is still the case that pre-training is the majority of the cost. I don't know what to expect in the future, but I could certainly anticipate a future where post-training is the majority of the cost.
In that future you anticipate, would it be the humans or the AI that's the costly thing for the post-training?
I don't think you can scale up humans enough to get high quality. Any kind of method that relies on humans and uses a large amount of compute, it's going to have to rely on some scaled supervision method, like debate or iterated amplification or something like that.
So on that, it's a super interesting set of ideas around constitutional AI. Can you describe what it is, as first detailed in December 2022 paper, and beyond that, what is it?
Yes. So this was from 2 years ago. The basic idea is, so we describe what RLHF is. You have a model, and it spits out like you just sample from it twice. It spits out two possible responses, and you're like, human, which response do you like better? Or another variant of it is rate this response on a scale of 1 to 7. So that's hard because you need to scale up human interaction. And it's very implicit, right? I don't have a sense of what I want the model to do. I just have a sense of like what this average of 1,000 humans wants the model to do. So two ideas. One is, could the AI system itself decide which response is better, right? Could you show the AI system these two responses and ask which response is better? And then second, well, what criterion should the AI use? And so then there's this idea, could you have a single document, a constitution, if you will, that says these are the principles the model should be using to respond? And the AI system reads those it reads those principles as well as reading the environment and the response. And it says, well, how good did the AI model do? It's basically a form of self-play. You're kind of training the model against itself. And so the AI gives the response, and then you feed that back into what's called the preference model, which in turn feeds the model to make it better. So you have this triangle of like the AI, the preference model, and the improvement of the AI itself.
And we should say that in the Constitution, the set of principles are like human interpretable. They're like
it's something both the human and the AI system can read. So it has this nice kind of translatability or symmetry. In practice, we both use a model constitution and we use RLHF and we use some of these other methods. So it's turned into one tool in a toolkit that both reduces the need for RLHF and increases the value we get from using each data point of RLHF. It also interacts in interesting ways with kind of future reasoning type RL methods. So it's one tool in the toolkit, but I think it is a very important tool.
Well, it's a compelling one to us humans, thinking about the founding fathers and the founding of the United States. The natural question is, who and how do you think it gets to define the Constitution, the set of principles in the Constitution?
Yeah, so I'll give like a practical answer and a more abstract answer. I think the practical answer is like, look, in practice, models get used by all kinds of different like customers, right? And so you can have this idea where the model can have specialized rules or principles. We fine tune versions of models implicitly. We've talked about doing it explicitly, having special principles that people can build into the models. So from a practical perspective, the answer can be very different from different people. Customer service agent, behaves very differently from a lawyer and obeys different principles. But I think at the base of it, there are specific principles that models, have to obey. I think a lot of them are things that people would agree with. Everyone agrees that, we don't want models to present these CBRN risks. I think we can go a little further and agree with some basic principles of democracy and the rule of law. Beyond that, it gets, very uncertain. And there our goal is generally for the models to be more neutral, to not espouse a particular point of view and, more just be kind of like wise agents or advisors that will help you think things through and will, present possible considerations, but, don't express, strong or specific opinions.
OpenAI released a model spec where it kind of concretely defines some of the goals of the model and specific examples like A, B, how the model should behave. Do you find that interesting? By the way, I should mention I believe the brilliant John Schulman was a part of that. He's now at Anthropic. Do you think this is a useful direction? Might Anthropic release a model spec as well?
Yeah, so I think that's a pretty useful direction. Again, it has a lot in common with constitutional AI. So again, another example of like a race to the top, right? We have something that's like, we think, a better and more responsible way of doing things. It's also a competitive advantage. Then others kind of, discover that it has advantages and then start to do that thing. We then no longer have the competitive advantage, but it's good from the perspective that now everyone has adopted a positive practice that others were not adopting. And so our response to that is, well, looks like we need a new competitive advantage in order to keep driving this race upwards. So that's how I generally feel about that. I also think every implementation of these things is different. So, there were some things in the model spec that were not in constitutional AI. And so, we can always adopt those things or, at least learn from them. So again, I think this is an example of like the positive dynamic that I think we should all want the field to have.
Let's talk about the incredible essay, Machines of Love and Grace. I recommend everybody read it. It's a long one.
It is rather long.
Yeah. It's really refreshing to read concrete ideas about what a positive future looks like. And you took sort of a bold stance because, like, it's very possible that you might be wrong on the dates or the specific applications.
Yeah. I'm fully expecting to, will definitely be wrong about all the details. I might be just spectacularly wrong about the whole thing, and people will laugh at me for years. That's just how the future works.
So you provided a bunch of concrete positive impacts of AI and how, exactly a super intelligent AI might accelerate the rate of breakthroughs in, for example, biology and chemistry that would then lead to things like we cure most cancers, prevent all infectious disease, double the human lifespan, and so on. So let's talk about this essay. First, can you give a high-level vision of this essay and what key takeaways that people should have?
Yeah, I have spent a lot of time, and Anthropic has spent a lot of effort on, how do we address the risks of AI, right? How do we think about those risks? Like, we're trying to do a race to the top, what that requires us to build all these capabilities, and the capabilities are cool, but, we're like a big part of what we're trying to do is address the risks. And the justification for that is like, well, all these positive things, the market is this very healthy organism, right? It's going to produce all the positive things. The risks, I don't know, we might mitigate them, we might not. And so we can have more impact by trying to mitigate the risks. But I noticed that one flaw in that way of thinking, and it's not a change in how seriously I take the risks, it's maybe a change in how I talk about them, is that, no matter how kind of logical or rational that line of reasoning that I just gave might be, if you kind of only talk about risks, your brain only thinks about risks. And so I think it's actually very important to understand, what if things do go well? And the whole reason we're trying to prevent these risks is not because we're afraid of technology, not